Let's go ahead and do it that way. So what's the first problem?
X minus 4,
X minus 12?
4.
X minus what?
X minus 4
4. I don't know why I was having such a hard time hearing that number. Okay.
over 3x squared minus 12x.
Like that?
No, the bottom
Bottom
3x squared.
minus 12x. Okay.
Yeah.
All right. Here, let me rewrite this. X minus 4 over 3x squared minus 12x minus 12 or minus 12x?
Minus 12x.
Like that?
No, it's only 112x.
So it's like that.
Yeah.
Okay. Now we're in business. Here, let me go down a little bit. Now, when you see an expression like that in the denominator, you know you can factor it.
Yeah.
And your mind always needs to be in factoring mode. Whenever you're dealing with these kind of problems, you want to factor that thing. Well,
Okay.
what's the greatest common factor that I can remove from that expression?
Would it be 4 or 1?
3x. Greatest common factor is what's the greatest thing that divides evenly into both terms?
2.
3x.
Oh.
And then what's left over has to be x minus 4. In other words, all I'm doing is splitting that up into two factors. And if you multiply these two factors on the right over here together, you get 3x squared minus 12x.
Yeah.
The advantage of factoring it is that now we have an x minus 4 in the numerator and we have an x minus 4 in the denominator. We can divide those out and we end up with this. Now, what's the question say? What are we supposed to do with this?
Factor completely first, and we're working with, it's called like big ones. So like, I think on the negative 4 parts, you would just do a big 1, like to cancel, because x negative 4 and x negative 4 both cancel out.
Oh, yeah, which leaves a 1 behind,
Yeah.
like that. And that's how
Yeah.
I got that.
Yeah, that's all it's asking.
Okay. Well, that is the answer, but not totally. In other words, if we go back and look at this before we cancel the x minus 4s, we've got some domain restrictions. X cannot be 4. If x is 4, we are dividing by 0. So this isn't really the complete answer. The complete answer is x cannot be 0 and x cannot be 4. Even though it looks like that 4 restriction disappeared when we canceled it, it never disappears.
So I'm just confused how you get those last two numbers.
Well, here's what we had. X minus 4 divided by 3x times x minus 4. Well, the one rule in mathematics says you can never divide by 0. Ever.
Yeah.
Well, what makes the denominator 0? X equals 0 would do it. X equal 4 would do it. So those are the two numbers that x can never be.
Okay.
Now, despite the fact that we cancel those, we do not lose that domain restriction. It stays with us. And in fact, it turns out to be a whole. For example, if I draw this thing, it's a hyperbola. But we've got this restriction that x can never be equal to 4, so there's a hole right there. And this is actually the way the graph would look.
Okay.
Okay, it wouldn't look just 3x. If I just had 1 over 3x, then it would look like that with no hole. But because I have this domain restriction here, that puts a hole right there. And it's an open one. It shouldn't be a closed one. But it is infinitesimally small, so you're not going to see it if you graph it on your graphing calculator. But nonetheless, it's there.
Okay.
All right, what else do we have?
All right. X squared minus 7x minus 30, and then over x squared minus 5x minus 24.
Again, we're looking at quadratics. We know the solution is going to be factoring.
Okay.
Factor the top.
7.
That's always the first step. Separate the x squareds.
So
Second step is both signs have to be opposite. It's the only way you can produce a minus 30 is if both signs are opposite. Third step is factors of 30 that subtract, because of that negative sign, to the number 7. What factors of 30 subtract to the number 7? Talk about factoring a number. Okay, there's always where I start. If I'm trying to factor 30, I know that two factors are 30 and 1. You with me?
yeah. Yeah.
Now what I do is I start cutting that in half if I can, and of course double that. So another set of factors are 15 and 2.
Yeah.
I can't cut 15 in half, but I can cut it by thirds. Well, if I'm cutting it by a third, I got to multiply this by 3. Now I can cut the 6 in half and double the 5. Bingo, I just found the two factors I'm looking for. In other
So
words,
would it be
7 and
10 and negative 3?
Subtract to the number 7. And now, depending on the sign of the middle term, you always put the biggest factor with that sign. The biggest factor is 10. It goes with the minus sign because the middle term has a minus sign. So that's how I factor the top.
Okay.
Now, let's do a similar thing on the bottom. First step, always do that. Second step, always determine both signs. Plus minus, again, it's the only way we can produce a minus 24. Third step, same as before, factors of 24 that subtract, because of that minus sign, to the number 5. Well, let's go through factors of 24. You do it. You do it for me. What's the next row?
12 times 2.
The next row?
8 times 3.
No, cut the 12 in half.
Oh, 6 times 4.
Cut the 6 in half.
3 times 2.
Now, if I'm cutting the 6 in half, I got to do 4.
3 times 8. Yeah.
Okay. Now I have found my factors of 24 that subtract to the number 5.
Okay.
So it's definitely 8 and 3. Now, which number goes with which sign?
So it'd be x plus 3 and then x minus 8.
Correct. And that cancels. So our final answer is x minus 10 over x minus 8. Now, again, they just wanted you to simplify this.
Yeah.
They
And then
didn't want you to graph asymptotes or
no.
poles or anything like that. Okay. Well, then we won't even talk about that domain restriction. Because
Okay.
this does have a domain restriction that x can't be equal to 8, because that would make the denominator 0. But if we go back, x also cannot be equal to minus 3, because that would have made that 0. So
Okay.
both of those carry forth, but they're not asking about this for now. They just want probably that as an answer.
No, I think she still wants those.
Really?
Yeah, but not. Yeah, she does.
Okay. Well, then that would be the complete answer.
All right. Do you want the next one?
Yeah.
X squared plus 3x minus 28, and then over x squared minus 49.
Again, a factoring problem. Both top and bottom. Now, the top is a typical factoring problem where you have both an x squared, an x, and a constant. So
Yeah.
we're going to factor that like we did everything else. What's the next step?
Work out so like 28 times 1.
Hold on. Actually, the next step is figure out what both signs are.
Oh. Would it be plus and minus?
Has to be. Now,
Okay.
it could be minus plus, but that's the same thing. As long as the coefficient of these x terms is the same, then plus minus is the same as minus plus. Okay, now the third step, factors of
What?
what's the third step? I'm looking for factors of what?
28.
That do what?
That go to 3. That like
Subtract.
subtract to 3.
Now, if that was a plus sign, then they would have to add to 3.
Okay.
So it all depends on what the sign of that is in front of the number. As long as it's a minus, then the factors of 28 have to subtract to 3. Now let's figure out factors of 28. Next row.
14 and 2.
Next row.
7 and 4.
That's all we need. Even if there were more, we wouldn't need to look at them. I don't think there are any more. I think those are the only 3 sets of factors. But we were looking for factors that subtract to 3. Now, which goes with the 7 and which goes with the 4? The plus or the minus?
X plus 7, x minus 4.
You got it. Now, the bottom one is not a typical factoring. It is what's called difference of perfect squares. In other words, if I have a squared minus b squared, that's the difference of perfect squares, it always, 100% of the time, factors into a minus b times a plus b. So in our case, I have x squared minus 49, so a must be x and b must be 7. In other words, a is going to be the square root of that, and b is going to be the square root of that. So how does x squared minus 49 factor? This time it's best to do one whole thing first.
So
What's that going to be? What's a minus b?
A minus B?
Yeah, it's x minus 7 times x plus 7.
Okay, that's what I thought.
Yeah, and
But,
when I say A, in other words, A was x and B
okay.
was 7, and I got B by taking the square root of that number.
Okay, yeah,
Got
I see
A
what.
by taking the square root of that number. And it's always A minus B times A plus B. So you do that whole term first, and then the next term's automatic. It's just the conjugate.
Okay.
Okay. Now, once again, we have something we can cancel. So our final answer is x minus 4 divided by x minus 7. And what restrictions do we have on x? What can x not be equal to?
Would it be 0?
No, x can be 0. What you can't have is a 0 denominator. You can have x be 0. You just can't have x minus 7 be 0, and you can't have x plus 7 be 0, because that would make the entire denominator 0. So
Okay.
x cannot be equal to 7, because that would make that 0. And even though it's gone, x still cannot be equal to minus 7, because that would make
Okay.
that 0.
So
So
it's whatever's on the bottom and what x cannot be.
no, it's you cannot divide by 0. That is the number one rule in math.
Okay, yeah.
Well, I'm dividing by the product of two things. If either one of these two things is 0, then I'm dividing by 0. So I cannot have x minus 7 be 0. That's verboten. And I can't have x plus 7 be 0. That's not allowed either. And those happen when x is equal to 7 or minus 7.
Okay.
So it's all about the denominator. It's not about x. It's about what makes the denominator equal to 0.
All right. 4x minus 4 over 6x minus 20.
Again, factor. What's the greatest common factor that comes out of the top?
4.
Leaving
1.
x minus 1.
Okay.
In other words, always make sure when you factor that when you put it back together again, you get what you started with. Well, this gives me 4x minus 4.
Yeah.
Exactly what I started with. So this is correct. But always do that check. You always got to check and make sure that you get what you started with. What's the greatest common factor out of the bottom?
Would it be 2?
Leaving
4.
Here's what you do. When you figure out your greatest common factor, you divide both terms by that.
Okay.
That's what you're left with. What is that?
6 over 2?
3x.
Oh, okay, yeah.
Now what's that equal to?
10.
Now, does these two things multiply together equal 6x minus 20?
Yes.
So we've done it correctly. And that's
Okay.
a check you should always do as you're doing the problem. You don't wait till the end and go back and check each step, because some problems have like 9 steps in them. And if you wait till the end and you get the wrong answer, you have no idea where you made the mistake. You got to go all the way back to the beginning. So it's a really good idea to check your math as you go. Now, I know that's the answer, except I can simplify that. What can I do? What's 4 over
Divided
2? What's 4 over 2 equal?
to -2?
No, just
Or
positive. Here's
Just
what I'm
2.
going to do. I'm going to divide the bottom by 2, and I'm going to divide the top by 2. I can always do that. I can divide the
Okay.
top and the bottom by the same number. That leaves that in the top and this in the bottom. There's my answer. I cannot simplify it any more than that.
Okay.
You do have a domain restriction. What is it?
Would it be 10?
No. Let's figure out how to do it. What I know is that the denominator cannot be 0, right?
Yeah.
So let's solve this equation. X equal 10/3. That's what it cannot be. If
Okay.
x were equal to 10/3, we would have a denominator of 0. Therefore, that's part of the answer.
Okay.
All right, what else?
6x cubed plus 42x squared over 2x squared plus 26x plus 84.
All right. What's the first thing we want to look at?
The top
Okay, what do we want to do to the top?
factor.
Okay, how should I rewrite the top?
Should you do 6x or is it just 6x?
Times what? What would I have to put in there so that it's equal to what I started with? What's the first term got to be?
X cubed.
Divide that by 6x. That's what you're doing. It's x squared.
Okay.
Notice that 6x times x squared is 6x cubed.
Yeah.
What's the rest of it?
42x squared.
Remember that it's got to multiply by 6x to give you 42x squared.
Oh,
So 7x. Which, here, let's start over again. My greatest common factor was actually 6x squared.
okay.
Let's do it down here. Notice why. I want the greatest common factor. I didn't recognize it until I did it the way you suggested, and I realized I can still take an x out of that.
Yeah.
So 6x squared, leaving behind x plus 7. Now, that times that is 6x cubed. 6x squared times 7 is 42x squared, so we've done it right. Now the bottom. When you're factoring a quadratic, it's always easier if this first coefficient is 1, not any number other than 1. So is there a way I can get rid of that 2?
Divide.
Factor it out. What's left when I factor the 2 out?
X squared.
Keep going.
And then, plus 13x
Keep going.
plus 42.
Okay. Now immediately we can see that 6 over 2 becomes
Is
3. But we can also see that we can factor the denominator. So here I'm going to go over here on the far left, and I'm going to write what we have at the moment. We now have 3x squared times x plus 7. in the numerator. And in the denominator, we have this quadratic. Well, factor that.
So factors of 42. So x plus x minus.
No. See, this is different. This has a plus sign in front of the 42. So both signs have to be the same. They either have to both be minus or they both have to be plus.
Okay.
And the sign on the middle term tells us they both have to be plus.
Okay.
Now, the third rule is slightly different. We want factors of 42 that don't subtract but add, because that's a plus sign.
Okay.
We want factors of 42 that add to 13.
So would it be 6 by 7?
There you go. And since both signs are the same, we could put the 6 there and the 7 there, or we could do it vice versa.
Yeah.
Okay. And again, we have a linear factor that cancels. So our final answer is 3x squared over x plus 6. That's the final function. What are the domain restrictions? What can x not be?
-7.
What else?
And would it be 13 over 42?
No. What you did was you figured out what it would take for that to be 0.
Okay.
Well, do the same thing over there. What does it take for that to be 0?
Oh, -6.
That's it. Simple as that. Okay.
Okay.
Now, when you get to it, and you probably will, when you start talking about vertical asymptotes and holes, the x minus 6, that's going to be a vertical asymptote. The x not equal to -7 is going to be a hole. And they actually have pretty important implications in how the graph looks. But just know that there's things like vertical asymptotes and holes, and you get them by whatever makes the denominator 0.
Okay.
Okay. That really is the first rule of mathematics. If you go on Google and you say the top 10 rules of math, every single list you get will say cannot divide by 0.
All right. 9x squared plus 81x over x cubed plus 8x squared minus 9x.
Okay, let's start at the top. It's clearly a factoring problem. What kind is it? Is it a typical quadratic factoring? Is it a greatest common factor? Is it a difference of perfect squares? What is it?
Would it be a greatest common factor?
Yes, what is the greatest common factor?
9.
9x. Don't forget the variable part also.
Okay.
In other words, I can divide both of these terms by 9x and have an even number. And that even number is x plus 9. Notice that when I multiply those two back together again, I get 9x squared plus 81x.
Okay.
Now, a clue that we can kind of discern from every problem we've had so far is that we're going to end up with a factor that's one of those two in the top, right?
Yeah.
Well, what's the first thing we can factor out?
X.
So let's do that. And that's going to leave x times x squared plus 8x minus 9. Now factor that. X and x. And you have a pretty good idea that one of the factors is probably plus 9, right?
Yes.
So let's just start there. Does that work? What's the other factor got to be?
Um,
You know the
oh,
sign?
would it be 1 or -1?
-1. First of all, you know the signs have to be opposite because that's the only way you can produce a negative sign.
Yeah.
And we need factors of 9 that subtract to the number 8.
Yeah.
But our big clue was that we knew we were going to get a factor that was the same as in the top. I mean, you don't know that in real life, but we've just seen 5 questions where that's always the case. And so this is probably going to be that same thing. Okay, so I can do that and that, but I can also do that and that.
Okay.
So I'm left with the only thing left in the numerator is 9, and the only thing left in the denominator is that. And what are my domain restrictions? What can
Um,
not be equal to?
1 and -9.
There's one other number.
Uh,
0 for that one right there.
oh, okay.
Notice that if x were 0, the entire denominator is going to be 0.
Yeah.
In other words, whenever you have numbers multiplied together that equal 0, one of them has to be 0.
Yeah.
So if any of these 3 x's were true, we would have a 0 denominator.
Okay.
Okay? And this one is still there. In other words, our final answer was 9 over x minus 1. So it's real clear that x can't be equal to 1. But it can't be equal to these other two also because of the original problem. You always go back to the original problem. And if I were to substitute -9 or 0 for x, my denominator is 0.
Okay.
Verboten. Okay, what else?
X squared minus 16
Different,
over.
difference of perfect squares. You want to get good at recognizing how best to factor, because all
Okay.
of these problems are always factoring problems. And there's really only 3 ways to factor. You start with greatest common factor. You don't see anything there, you look to difference of perfect squares. If you don't see anything there, you go to quadratic factoring. Well, I can immediately see that's difference of perfect squares. What's it over?
X squared. And then it's the entire equation is multiplied by and then by x squared minus 4x over x squared subtract x subtract 12.
Okay. Again, a total factoring problem. And you just do piece by piece. Factor the top left.
X minus 8 and x plus 8.
It's the square root of 16.
Oh, so x minus 4 and x plus 4.
Yeah, notice that when I multiply it back together again, I got to get 16. Well, you get 16
Okay.
as the last term that you're foiling. Minus 4 times 4 is minus 16. Okay. The bottom we'll just leave as, we'll leave it as x times x. That's x
Okay.
squared. Okay. Now we're multiplying that and factor the top.
Would it be the top right?
Yes, sorry.
Uh, x minus 2 and x positive.
No,
X minus
this is not difference of perfect squares. This is a greatest common factor. What's the greatest common factor you can take out of that?
2.
Not 2, x.
Oh,
Remember
okay.
that the greatest common factor has to divide into both terms evenly.
All right.
That's the rule. Okay? And those two multiplied together give you x squared minus 4x.
Okay.
Now, let's look at the bottom right. This is a typical quadratic factoring. In other words, this is where we use those simple rules. What are both signs? They equal or
So plus and minus.
now factors of 12 that subtract to what?
12.
To 1. The coefficient of the middle term. That's what those factors have to subtract to. Is the coefficient of the middle term, and that is 1. Even though we don't see it, we know it's 1.
So would it be x plus 6, x minus 6?
They have to multiply to 12, those two numbers.
Oh, 3. X plus 3. And, oh, no, it's
You actually had it right. X plus 3, x minus 4.
okay.
Okay. Now that I've factored all four ends, both tops and both bottoms, I can start going crazy with canceling. Okay? I can cancel that with that. I can cancel that x with that x. And I guess that's it. My answer is whatever's left over. I've got that in the top. I got an x minus 4 over there. And down below, I have an x and an x plus 3. And there's no need to multiply those two back together. That's your answer right there.
Okay.
Factored form is actually a better answer than multiplied back together again, believe it or not. You always prefer factored. You don't factor it necessarily unless there's a good reason to do it, but if you have gotten to your answer and it's in factored form, leave it in factored form. Don't multiply it back together. Now, I've been dealing with students for 8 years on these kind of problems, and I never get what the domain restrictions are. You sure that's going to be part of your answer? I don't think so, but you could be in an unusual class. In other words, I think that's all she wants right there.
Yeah.
Male or female teacher?
Female.
Okay. In other words, the exact answer is this, but x can't be equal to 0. Well, we can see that. X can't be equal to minus 3. We can see that. But x also can't be equal to 4. From that x minus 4 that got canceled out, that domain restriction applies. But I honestly don't think you have to worry about this. I've never had a student have these kind of problems where you had to list these extra domain restrictions. That's just that's not the point of this exercise. The point of this exercise is whether you can factor or not.
All right.
Notice that we have to do all kinds of factoring here. We had to do difference of perfect squares. We had to do greatest common factor. And we had to do normal quadratic factoring. Those are the 3 types of factoring that you have to do. And you should always look to do them in that order. Well, actually the order is greatest common factor, look to that first, then dopes, difference of perfect squares, and then quadratic factoring.
Okay.
So that's the order you always want to consider your factoring. Don't look for quadratic first, because sometimes once you take the greatest common factor out, you're left with something that's a normal quadratic factor.
Yeah.
So always look to do them in this order. Okay, what else you got?
Y squared plus 10y plus 25 over y squared minus 9, and then multiplied by y squared plus 3y over y plus 5.
Another problem, we're going to get to use every type factoring.
Okay.
Okay, let's start with the upper left. I'm going to go down here. Factor that upper left. Standard quadratic factoring. In other words,
So
there's no greatest common factor, and it's not difference of perfect squares.
would there be a y outside of the two brackets?
No.
No? Okay.
Our first thing is to split the y's up. Just like if it was x, we'd be splitting it up into x and x.
Okay.
What do both signs have to be?
5.
Signs, plus or minus.
Oh, plus.
Both have to be plus. And you're right, it's 5 and 5. So that's how the top left factors. Bottom left, what kind of factoring are we going to use here? What's it called?
Is it the perfect square one?
Dopes. Difference of perfect squares. And the reason
Okay.
it's called that is because that's a y squared is a perfect square, 9 is a perfect square, and they're being subtracted. So it's difference of perfect squares. What does it factor into?
Is it y plus 3, y minus 3?
Yes. So that's fully factored. Now let's go over here. What are we going to factor out of the top? What form of factoring are we going to use that? It's not a standard looking quadratic, and it's not difference of perfect squares.
Would it be GCF?
Must be GCF. What's the GCF?
Y
What's left over?
3.
Always start with that.
Oh, y. Yeah.
Y
So y
three.
plus 3.
And then check it. As you're doing it, check it. If I multiply that back together again, I get y squared plus 3y. Now, the bottom right can't be factored.
So does it just stay the same?
Yeah. But notice, I can cancel it now, because I got a y plus 5 up there. Cancel that. I got a y plus 3 there. I can cancel with that. So our final answer, the only thing I have left in the numerator is a y times y plus 5. See that? In other words, that
Yeah.
y and that y plus 5. And in the denominator, I just have a y minus 3. That's the only thing left. When I say the only thing, these turn into ones. When you were saying the big one,
Yeah.
I think that's what you were meaning. But ones, we don't have to write them.
Okay.
Okay? So this is my final answer. Can't be simplified anymore. Now I could multiply the two numerators together, but better to leave it in factored form. Always.
Yeah.
Okay, what else?
So 30 over y squared plus 4y minus 12. And then divided by 6y over y subtract 2.
Okay. Now, division, what's the easiest way to handle that?
Turn into multiplication.
Yes. So we're going to make it multiplied by the reciprocal, y minus 2 over 6y.
Okay.
So we lose this, and we get it back to a multiplication problem. And you always want to do that. Okay? Now, the only thing I can see that can be factored is what?
The bottom left.
Okay? What does it factor into? By standard quadratic factoring.
So turn So it'd be y.
Start with, yeah, just use a methodology here. Don't,
Okay.
don't try to figure out the answer in one step. That is a big mistake with factoring. Just go through the 3 steps. Split the y's up, and they always go y and y. Next thing, determine both signs. What do both signs have to be?
Plus minus.
And next, the third step is factors of 12 that subtract to the number 4.
Oh, so would it be 2 and negative 6?
Just 2 and 6, and put the larger of those factors with the sign of the middle term. So where's the 6 go?
Would that be negative?
No, the larger, here's our 2 factors, 6 and 2. Take the larger one and put it with the sign of the middle term, which is plus. So
Okay. Oh, yeah.
that's what I mean when I say that. Okay?
All right.
Now start canceling. What can we simplify?
Y and negative 2.
What else?
With the 6.
Well, I can certainly divide 30 by 6. So 30 over 6 can be simplified.
Oh.
Not this 6 over here. This 6 here.
Okay.
What's 30 divided by 6?
5.
Okay, that's the only thing left in the top. The bottom, the only thing left is y plus 6 times x. In other words, this 6 goes away when I change that to a 5. Is that supposed to be an x or a y? That's a y, isn't it? There's the answer. Only problem about working with x's and y's is sometimes your y's look like x's. My y's look like x's. This whole thing was in y, right? There were no x's in it?
Yeah.
Okay, that's what I thought. So that's the answer there. Again, we're not going to address domain restrictions. I honestly don't think that's what she's looking for here. Right? What else we got? We got about 10 minutes.
X squared plus 3x minus 28 over x squared plus 4x plus 4, and then divided by x, and then like on top x squared minus 49, and x squared, and then on top then x squared minus 5x minus 14.
Okay, I just skipped a step,
Yeah, I see.
and this is correct, correct? In other words,
Yeah.
it's originally divided by the x squared minus 49 was in top.
Yeah.
Okay, so all 4 of these can be factored. So
Yes.
let's do it. Start on the top left.
So it'd be x and x, and plus minus.
What's the rule? What's the next part?
So factors of 28.
The do what?
That subtract a 3.
Perfect. What are they?
Yeah.
What are those factors?
So 14 to 7 4. So it'd be x plus 7 and then x minus 4.
Perfect. I'll do the bottom.
X squared plus. So it'd be x and x. Would it be plus plus? And then
factors of 4 that do what?
that equal 4?
That add. In other words,
Add
if
4?
that is a plus sign, they got to add to the middle number. If that's a minus sign, they got to subtract.
Okay. So 2 and 2? X plus 2, x plus 2.
Okay? Factor the top right.
So it'd be x and x. And would it be minus minus?
You cannot produce a minus 14 if it was minus minus.
Oh, okay, plus minus then.
When there's a minus sign in front of the constant, it's always plus minus.
Okay.
In other words, the signs have to be opposite. Remember, the last step of FOIL is to multiply those two last terms together.
Okay.
When that was done, we got minus 14. So it has to be opposite signs. Now what? Factors of
14
that do what?
would subtract 5.
Okay, what are those?
X plus 7, x minus 2.
The bigger factor has to go with the sign of the middle term.
Oh, okay, x minus 7, x plus 2.
Bottom, how do I factor that? What is that called?
Is that GCF?
Is there a GCF?
Oh, no,
No, it's not that. What's the second method?
it's,
Dope.
is it dope or dope?
Dopes. What does dopes stand for?
Difference of,
Perfect.
I'm not
Difference
of
of perfect squares.
difference of perfect squares.
And it's called that because x squared is a perfect square and 49 is a perfect square. If that was 48, I wouldn't be able to use it because 48 is not a perfect square number. So in order to use dopes, both of these have to be perfect square numbers.
Okay.
What's the answer? X what?
X plus 7, x minus 7.
Uh-huh. Now cancel wherever you can. What are you left with?
X minus 4 over x plus 2.
That's it. That's how you do all of those problems. They're just factoring problems. And you're always going to have tons of stuff to cancel. They set them up like that. Okay. We got time for one more.
All right. 2x squared plus 7x minus 15. And then over 4x squared.
Let's stop for a moment. We'll talk about factoring that. Everything we've factored so far in terms of normal quadratic factoring, the coefficient of the x squared was a 1.
Yeah.
It's a 2. If it's not 1, it's a considerably more difficult thing to do. Still break up the x's.
Okay.
The next step is I still need to figure out both signs. Well, I know both signs have to be opposite because otherwise I cannot produce a minus 15. But plus minus is not the same as minus plus here. I have to allow for either one.
Okay.
And now I got to throw my rule book out the window. I can't talk about factors of 15 doing anything. It's not factors of 15 that subtract to 7 anymore. It's not factors of 15 that add to 7. It's just factors of 15 and you kind of do trial and error. Okay? Well, 15 doesn't have a lot of factors. That's it. And when you're doing trial and error, just pick the two closest together factors as your starting spot.
Okay.
Okay. And I am going to try 5 and 3 randomly. I'm just going to start there. And I'm going to keep trying alternatives until I produce this middle term of 7x. Well, the middle term always comes from the inside and the outsides multiplied together and added. Well, that's plus 5x. That's minus 6x. That would give us a middle term of minus x, which we don't have. So that's not the answer. So let's try the 3 there and the 5 over here. Now the middle term is plus 3x. The outside term is minus 10x. That gives us minus 7x. Well, that's the right number, but the wrong sign.
Okay.
That tells me is all I have to do is move those numbers down. That's going to be the right answer.
Okay.
And I can prove it because that times that is minus 3x. That times that is plus 10x. Add them together, I get plus 7x. And that's how you do this kind of factoring. It's far different. You can't rely on those simple rules that you can with really elementary ones.
Yeah.
But it's a trial and error process. And usually these aren't that hard because they don't give you that many factors of this number here. Notice they only gave us a number like 15. They didn't give us a number like 16 that has a gazillion factors. So usually they'll give you numbers where you don't really have to try that many combinations. But it is a trial and error process. So our answer is 2x minus 3 times x plus 5. And if we multiply that back together again, we'll see we do get that. Okay. That's probably a good place to stop. I do have another session at 4. And I interrupted you on this problem just to tell you how you factor second degree difficulty quadratics.
Okay.
Okay. So let's see. I think you have Lachlan. Is that what everybody calls you, is Lachlan?
It's pronounced Lachlan.
Lachlan, okay. My apologies. We have a session scheduled for next Tuesday at 3.
Yeah.
Now, for that session, I won't call you, as all I will do is text you the meeting ID number.
Okay.
You have the app on your tablet now.
Yeah.
So it's all you have to do to enter a meeting is to open that app and put in the meeting ID number that I text you. And then we'll be in a meeting just like we are now.
Okay.
And so it's only the first time that I call people because it takes a little bit of verbal assistance to get the software in the first place. After that, the only thing you need is a meeting ID number. I will text it to you.
All right.
I will talk to you next Tuesday, Lachlan.
All right. Thank you.
You're welcome. Have a good weekend. Bye-bye.
You too.